Look at that condenser coil, the one sitting outside your house right now. If you walked out there and ran your finger along those aluminum fins, you would probably pull back a pad of grey felt, matted dust and pollen, and cottonwood seed packed so tight it looks like dryer lint. According to the EPA, a layer of that grime just 0.042 inches thick, about 1/23 of an inch, causes a 21% drop in your system's cooling efficiency. Your air conditioner does not make a sound when that happens. It does not throw an error code. It just runs longer, pulls harder, and your electric bill climbs by a fifth, while the house feels exactly the same. But the strange part is not that it happens. The strange part is that in Japan, the average homeowner already knows this and does something about it every 2 weeks. In the United States, most homeowners never touch the parts that actually drive their cooling costs. This video is going to show you which parts those are, what Japanese households do differently, and how to close that gap yourself in order from the easiest fix to the hardest without replacing your unit. The average American household is projected to spend $778 cooling their home this summer alone, according to the National Energy Assistance Directors Association. That number is up almost 9% from last year, and a meaningful portion of it, anywhere from $100 to $200 over a single summer, goes to waste because of maintenance. The homeowner never performed on parts they may not even know exist. So where does that waste actually come from? Think of your air conditioner as a heat pump, because that is literally what it is. It does not create cold air. It absorbs heat from inside your house and dumps it outside. The indoor unit pulls warm air across the evaporator coil, where refrigerant absorbs the heat. That refrigerant travels through copper lines to the outdoor condenser unit, where a second coil releases the heat into the open air. A fan blows across those outdoor coil fins to help the heat escape. Then the refrigerant loops back inside and does it again. Every surface in that loop is a place where dirt can slow the transfer down. And when the transfer slows down, the compressor has to run longer and harder to move the same amount of heat. That is the mechanism behind every inflated cooling bill from a system that technically still works. The unit is not broken, it is choking. Now here is where Japanese residential AC culture comes in. And this is not a gimmick or a social media trend. It is a genuine structural difference in how the two countries approach the same appliance. In Japan, ductless mini-split systems dominate the residential market. Over 90% of new residential mini-splits sold in Japan are inverter-based, according to market data from 2024. These wall-mounted indoor units sit right there in the room with you. You can see the filters. You can pop the front panel and look at the coil. The outdoor unit sits on a bracket outside your window, not in a mechanical closet or up on a roof slab. In the United States, most homes run central air conditioning. The evaporator coil is buried inside a plenum above your furnace, usually in the attic or a utility closet. The condenser sits outside behind the house or on the roof, where you walk past it every day without thinking about it. The air filter is behind a return grill in the hallway ceiling, and the only reason most people ever open it is because a sticker on their furnace told them to change it every 90 days. The practical effect of that design difference is visibility. In Japan, the parts are in your face. In the United States, they are out of sight and out of mind. And out of mind is where the efficiency losses pile up. There is also a technology difference worth mentioning. Inverter-based mini-splits, which dominate the Japanese market, use a variable speed compressor that adjusts its output to match the cooling load. When the room is almost at the target temperature, the compressor slows down instead of cycling off and back on. That constant adjustment uses less energy than the on-off cycling of a standard central air compressor, which runs at full speed until the thermostat is satisfied and then shuts off entirely. The inverter approach is more efficient, and it is also gentler on the compressor because it avoids the surge of a cold start every time it kicks in. This is not something you can retrofit, but it is worth understanding if you are ever in the market for a new system. Japan's Ministry of Economy, Trade and Industry, known as METI, reports that air conditioning and heating account for approximately 30% of household electricity consumption in Japan. That makes the AC unit the single biggest electricity draw in the average Japanese home. Because of that, the maintenance standards are not casual. METI recommends cleaning your air conditioner filters every 2 to 4 weeks during peak cooling season. Compare that to the standard American advice of replacing your filter once every 1 to 3 months. That frequency gap is not arbitrary. The U.S. Department of Energy has published data showing that replacing a dirty air filter with a clean one can reduce your air conditioner's energy consumption by 5 to 15%. A filter that has been sitting there for 3 months in a house with pets or in a neighborhood with construction dust or heavy pollen is not restricting airflow a little. It is restricting airflow a lot. And when airflow drops, the evaporator coil gets too cold. Moisture freezes on the surface instead of draining. And now you have an ice problem on top of a dust problem. Your air filter is the single easiest maintenance task you can do. It takes less than 5 minutes. The filter itself costs somewhere between $3 and $15 depending on the type. And doing it every 2 weeks instead of every 3 months keeps the airflow consistent, which keeps the coil temperature where it belongs, which keeps the compressor from running overtime. METI's data suggests this kind of regular filter maintenance alone can reduce electricity costs by 15 to 25%. That is the cheapest energy savings you will ever find. Once you are past the filter, the next part most homeowners ignore is the condenser coil, the big metal box sitting outside your house with a fan on top. That outdoor unit is the release valve for all the heat your system pulls from inside. The condenser coil wraps around the inside of that housing, and its thin aluminum fins are designed to let air pass through freely so the heat can dissipate. But those fins are exposed to everything. Grass clippings from the mower, cottonwood fluff in May and June, pollen, dust, spiderwebs, leaves, pet hair drifting across the yard. Over a season, that buildup forms an insulating blanket on the coil surface that blocks airflow exactly the way a clogged air filter does inside the house. The Department of Energy reports that dirty condenser coils can increase your system's energy consumption by up to 30%. That is nearly a third of your cooling electricity going to waste because the outdoor unit cannot breathe. And here is the part that matters for your wallet specifically. The EPA study found that a dirt layer, just 0.042 inches thick, thinner than the edge of a credit card, causes a 21% drop in efficiency and can increase refrigeration energy use by 35%. Cleaning the condenser coil is not complicated, and it does not require a technician for routine buildup. Turn off the system at the electrical disconnect, which is the gray or beige box on the wall near the outdoor unit. Remove any visible debris from around the housing. Then spray the coil fins from the inside out with a regular garden hose, working top to bottom, so you push the dirt out the way it came in. Do not use a pressure washer, because the fins are thin and they bend easily, and bent fins block airflow just like dirt does. If fins are already bent, a fin comb will straighten them. You can buy one at a hardware store or online for under $10. It looks like a small metal comb with teeth spaced to match the fin spacing on your unit. Run it gently down the bent section and the fins spread back into position. That is a $5 tool doing the work of a $100 service call. This entire condenser cleaning takes about 30 to 60 minutes, once a year in the spring before cooling season starts. And the total supply cost is under $20 if you already own a garden hose. The DOE identifies coil cleaning as one of the most impactful maintenance tasks a homeowner can perform. Now we move to the part that trips people up, the evaporator coil. This is the indoor coil, where the refrigerant absorbs heat from your air. On a central air system, it sits in the plenum, the sealed metal box above your furnace, behind an access panel you may have never opened. On a mini-split, it is the coil behind the front panel of the wall unit. A 2023 peer-reviewed study found that a dust layer of just 0.02 inches on an evaporator coil reduces heat transfer efficiency by 15% and airflow through the coil by 11%. That is the equivalent of throwing away roughly 1 month of cooling electricity every year. And because the evaporator coil operates wet, Condensation is always forming on its surface as it pulls moisture out of the air. That dust mixes with water and becomes a sticky layer that does not blow off the way dry dust sometimes does from the condenser. This is also where the mold problem starts, and this is exactly where the Japanese practice of naibu-kurin comes in. Naibu-kurin, written in Japanese as a compound of the words for internal and clean, is a function built into most Japanese air conditioners. When you turn off the cooling, the system automatically switches to fan-only mode and runs for 30 to 90 minutes, sometimes up to 2 hours on certain models. The purpose is simple. It dries the evaporator coil and the interior surfaces of the unit after every cooling session. Why does that matter? Because when your air conditioner cools the air, moisture from the room condenses on the cold evaporator coil. When you shut the unit off, that moisture just sits there in the dark. Mold spores are already in the air. Give them a wet surface in a dark enclosure, and colonies start forming within days. Once mold takes hold inside the unit, it does two things. It restricts airflow across the coil, which lowers efficiency, and it blows spores into your living space every time the system runs, which is a health issue on top of an energy issue. In Japan, where summers are humid and the rainy season runs through June and July, this is considered standard operating practice. Most Japanese AC units have the naibu-kurin function set to run automatically. Guides for foreign residents in Japan consistently list enabling this function as one of the most important things you can do for long-term unit health and air quality. You can replicate this on any system. If your air conditioner has a fan-only mode, run it for 30 minutes after your last cooling cycle of the day. On a central air system, switch the thermostat fan setting from auto to on for half an hour after you turn off the cooling. This circulates air across the wet coil, dries the surface, and starves the mold of the moisture it needs. It costs almost nothing in electricity because the compressor is off and you are only running the blower fan. If the evaporator coil is already visibly dirty, or if your system smells musty when it kicks on, the coil needs cleaning. On a mini-split, you can access it by popping the front panel and lifting out the filters. Foam no-rinse coil cleaners, available at any hardware store for around $8 to $12, spray on and drip off into the drain pan. On a central air system, you may be able to access the coil through the plenum access panel. But if the buildup is heavy, this is where a professional cleaning makes sense. The evaporator coil is close to the blower motor, the drain pan, and electrical connections, and a wrong move with cleaning solution can cause problems. Professional evaporator coil cleaning typically runs $100 to $400 as part of a maintenance visit. There is another Japanese AC practice worth understanding before we move to the thermostat, and it is one that saves energy in a way most people do not think about. Japanese air conditioners have a mode called joshitsu, the Japanese word for dehumidification. During Japan's rainy season, which runs roughly from June through July, humidity levels regularly push past 80%. Rather than running the AC in full cooling mode, which hammers the compressor, Japanese households switch to joshitsu mode. The system runs the fan at a slower speed, passes air over the cold evaporator coil to condense moisture out of it, and returns drier air to the room without aggressively dropping the temperature. The energy savings come from the reduced compressor load. In full cooling mode, the compressor runs hard to push the room temperature down. In dry mode, the compressor cycles less frequently because the target is humidity, not temperature. For mild, sticky days where the heat is not extreme but the air feels heavy, dry mode uses noticeably less electricity than cranking the cooling down to 72 degrees. Most ductless mini-splits sold in the United States already have a dry mode. The button is usually labeled with a water droplet icon on the remote. Central air systems do not typically have a dedicated dehumidification mode, but a whole house dehumidifier installed in the ductwork can achieve the same result. The point is not that every American home needs to replicate every Japanese AC setting. The point is that humidity control and temperature control are two separate levers, and most homeowners only ever pull one of them. One more part that gets overlooked, and this one causes problems that look unrelated to the AC itself. The condensate drain line. Every air conditioner produces water as a byproduct of cooling because moisture from the indoor air condenses on the evaporator coil and drips into a drain pan underneath it. From there, a small PVC pipe carries the water outside or into a floor drain. Over time, algae, mold, and mineral deposits can build up inside that drain line and block it. When the line clogs, water backs up into the drain pan and eventually it overflows. That overflow can damage ceilings, walls, and flooring, and it can also trigger a safety switch that shuts down the entire system. Your AC stops cooling, you call a technician, and the fix turns out to be a clogged drain line that you could have cleared yourself. Clearing the line is simple. Pour a cup of distilled white vinegar into the drain pan or the access point on the drain line once a month during cooling season. The vinegar kills the algae and dissolves the buildup. If the line is already clogged, a wet-dry vacuum applied to the outdoor end of the drain pipe will usually pull the blockage out. This is a 2-minute job that prevents a potential water damage claim on your homeowner's insurance and a $200 service call. Here is a good place to talk about the thermostat, because this is another area where the Japanese approach differs from the American default, and the data behind it is specific. Japan's Ministry of the Environment recommends setting your air conditioner to 28 degrees Celsius, which is about 82 degrees Fahrenheit. That sounds high to most American homeowners, who tend to set their thermostats somewhere between 70 and 74 degrees. But the ministry's data, echoed by multiple Japanese energy guides, shows that each degree you lower the cooling temperature adds approximately 10% to your AC electricity costs. Going from 78 to 72 degrees, a common American preference, is not a 6-degree drop. It is roughly a 60% increase in cooling energy. The practical move here is not to live at 82 degrees if that makes you miserable. The practical move is to find the highest temperature where you are still comfortable and stay there. A ceiling fan in the room lets most people tolerate 2 to 3 degrees warmer without noticing, and the fan uses a fraction of the electricity the compressor does. Combining a higher set point with a fan is one of the simplest savings moves available, and it is standard practice in Japanese homes. Now, the part that needs a clear line drawn around it, because this is where homeowner maintenance ends and licensed technician work begins. If you have cleaned your filters, washed your condenser coil, dried your evaporator, and your system is still not cooling the way it should, the problem may be refrigerant. And refrigerant is not something you diagnose or handle yourself. The reason that line is important is that dirty coils and clogged filters produce symptoms that look identical to low refrigerant. Both cause the evaporator coil to run too cold. Both produce weak airflow. Both make the system run longer cycles without reaching the set temperature. Both can cause ice to form on the coil or the refrigerant line. A homeowner who calls a technician without cleaning the system first is at risk of paying for a refrigerant recharge that does not fix the underlying problem because the underlying problem was dirt, not gas. But here is the other side. If the refrigerant charge is genuinely low, that means there is a leak somewhere in the sealed system, and leak detection and repair is skilled work. Refrigerant itself is a controlled substance handled under specific regulations. In Japan, the High Pressure Gas Safety Act requires licensed technicians for any work involving refrigerant, and DIY installation voids the unit's warranty and violates building codes. In the United States, the EPA regulates refrigerant handling under Section 608 of the Clean Air Act. Either way, this is not a garden hose job. The same rule applies to the electrical disconnect box, the capacitors, and any wiring inside the outdoor unit. Capacitors store a potentially lethal charge even when the system is powered off. If you open the condenser housing and see a cylindrical silver or black component mounted on the inside wall, close the panel and call a technician. That is a capacitor, and it needs to be discharged by someone who knows what they are doing. So, what does a professional service call actually cost? And when is it worth scheduling one? An HVAC service call runs $75 to $200 just for the technician to show up and diagnose the problem. That fee typically covers the first hour and does not include parts, refrigerant, or additional labor. If the diagnosis leads to a repair, most companies apply that fee toward the total bill. A routine annual maintenance visit, which usually includes a coil inspection, refrigerant pressure check, electrical connection tightening, and condensate drain clearing, runs $150 to $350. That might sound like a lot for a checkup, but the alternative math looks worse. A compressor replacement, the single most expensive repair on a residential AC system, runs $1,500 to $3,000 installed. And dirty coils are one of the leading causes of compressor failure, because a compressor working against restricted airflow runs hotter, cycles more frequently, and wears out faster. Industry data shows dirty coils can increase compressor runtime and wear by up to 35%. An annual tune-up that catches a dirty coil before it kills the compressor is not a maintenance cost. It is insurance against a multi-thousand-dollar repair that your homeowner's policy does not cover. There is a timing trick here that saves money too. Schedule your maintenance visit in early spring, before the first heat wave of the year. Once temperatures hit the 90s, every HVAC company in your area is booked solid with emergency calls. You will wait longer, and you may pay a premium for the visit. A spring tune-up catches problems before the system is under full summer load, and many HVAC companies offer off-season discounts in March and April. That same $200 visit might cost $150 in the spring and $250 on the first 95-degree day in June. Here is the full maintenance calendar, organized by frequency, with a clear line between what you do and what a technician does. Every 2 weeks during cooling season, clean or replace the air filter. If you have a reusable mesh filter, like the kind found in most mini-splits, take it to the sink, rinse the dust off under warm water, let it air dry, and slide it back in. If you have a disposable filter in a central air return, swap in a fresh one. This is a 5-minute job that the DOE says is worth 5 to 15% of your cooling energy. Every month during cooling season, check the area around your outdoor condenser unit. Clear any leaves, grass clippings, or debris within 2 feet of the housing. Trim back any vegetation that has grown close to the unit. The condenser needs unobstructed airflow on all sides to release heat properly. Once a year, in spring, before you start running the AC for the season, do the full condenser coil cleaning. Kill the power at the disconnect. Remove the top grill or fan assembly if your model allows it, and hose the coil fins from the inside out. Straighten any bent fins with a fin comb. Inspect the condensate drain line while you are there and clear it if it looks sluggish. Once a year, schedule a professional maintenance visit. A technician will check refrigerant levels, inspect electrical connections, clean the evaporator coil if it needs it, verify thermostat calibration, and test the system's overall performance. That is your baseline for the year. After every cooling session, or at the end of each day, run the fan for 30 minutes to dry the evaporator coil. If your unit has an internal clean function, turn it on and leave it set to automatic. If it does not, switch the fan to the on position manually and set a reminder. At the start of the season, check your thermostat setting. Try raising it 2 degrees above wherever you normally set it and adding a ceiling fan. If your comfort level stays the same, you just saved yourself roughly 20% in cooling electricity based on the 10% per degree guideline. And you did it without touching a single part. None of this requires a new air conditioner. None of it requires expensive equipment. The difference between a system that runs efficiently and one that wastes a quarter of its electricity is a clean filter, a rinsed coil, a dry evaporator, and a thermostat that is not set 6 degrees lower than it needs to be. Japanese homeowners do most of this as routine because their systems put the parts where they can see them. American homeowners skip most of it because their systems hide the parts behind panels and housings and ceilings. The fix is not a cultural revelation. It is a maintenance checklist. The parts are the same. The physics are the same. The only thing that changes is whether you actually open the panel and look. If you found this useful, subscribe. I cover the maintenance and money-saving side of home systems, one part at a time. The next video covers the 5 signs your ductwork is leaking conditioned air into your attic, and what that is doing to your bill every month.